Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we are going to continue our learning on LNG network modeling. All right, and we arrive at the point where we will define the LNG plant. In previous videos, we have discussed about the reservoir, the ample software, and also the well, the prosper file, right? Now we need to define the LNG plant, okay? And you can see the icon here, the LNG plant. To define the LNG plant, double click on this element, this icon, and navigate. Here we have this summary. Now we can go to the input. Okay, but let's check the summary first. So the label, LNG plant, you can also give the name and your comments. And the separation type, it's LNG process plant. Okay, data summary, plant process. Okay, you can enter this one. That's in the input, constraint none. Okay, and schedule some, but we will arrive at this point. Okay, so that's it for the summary screen. Now let's go to the input. Okay, process plan or plan process. Okay, originally it is blank. It was blank. And we will populate this table with data. Okay, in this section, we specify the overall composition of the fluid along with the fraction of the components that will make up the produced LNG and also the condensate. Okay, and as I said before, this was blank, and we populate the data into this table by using this button, populate from PRP file. Okay, to import the composition, we select this button, populate from PRP file, and it will import the PVT model file that was pre-generated in PVTP. GAP will then use this composition that is associated with this PRP file. Okay, but before clicking on this button, let's see what we have in this table. So component name, okay, the pure component as well as the pseudo components, and then the percentage in the LNG phase, 100% C1. Okay, it's actually methane but liquefied. And for fuel, we have this, whereas for the condensate, we start from C6. Okay, but this is the table. Okay, the original data comes from the PRP file. So that's why we click on this button, PRP file. Okay, this is the model, the PVT model. It was prepared in PVTP. It was pre-generated in PVTP. Okay, so you handle everything in PVTP, and then you export the EOS model, the PVT model or the fluid model into this PRP file format. Okay, so after you select this one, just click on this button, and it will populate the table with the data. Okay, it's like this. Okay, but once again, okay, but by the way, it's 0, so it's a bit weird. Okay, what should we do now? I'm going to open the PRP file using Notepad, and we will see whether the composition in the file, in the PRP file, actually only 0, like this. Okay, so now let's go to the PRP file. Okay, so now let's see here. This is the PVT model, the PRP file. Right click and then open with. I'm going to open this with Notepad. Okay, so this is what's inside the PRP file. Actually, we already have the mole percentage, yeah, in percent. Also with the critical temperature and then critical pressure, eccentric factor, and so on and so forth. Okay, as usual, the critical volume, the volume shift, the paracore, omega A and B. Okay. Binary interaction coefficient only non-zero. And then this is the separator, 2 stages, reference temperature 255. So this is what's inside, the PRP file. We have 16 component, no lumping. Okay, so this is actually the file. And when we import or populate the gap with this data, actually the composition is already transferred into the gap. Okay, now what we need to address is the fraction of the component that will make up the LNG. Okay, because the fraction of the component that will make up the LNG, LPG, and so on and so forth, actually determined by our process, by the LNG plant process. It's not addressed in PVTP. It's another job done by process engineering job, process engineering software. The fraction of LNG, the fraction of LPG, right? So we need to differentiate between the fluid composition generated in PVTP and the fraction of each component in LNG, LPG, and condensate, because determined by our process, by the process engineering. Okay, so I'm going to close this file and let's go back to the gap. Okay, so now let's deal with it. So in LNG, it's 100% C1. So actually 100% of the C1 will go to the LNG. That's why the condensate will be calculated, and the rest for the LNG, for the condensate, I mean, will be 0, because all the C1 in our process will go to the LNG phase. N2 will not go to the condensate phase. It will be the fuel and flare 100, 100, 100, all the way to normal pentane. Sorry. Okay. So our hexane and the pseudo components, the heavier components, will go or will be the condensate, will make up the condensate. Okay. So that's what I mean by, dividing the LNG plant. Okay. We will not, in GAP, we will not deal with all the process, the steps, the chemical engineering job that will make the C1 from our, reservoir fluid to be the LNG. No, it's not a process. It's not a chemical engineering software, actually. So we will not deal with the distillation. I don't know what to call the process, what the process are, distillation or separation. We don't know, but we can directly define the product here. So C1 will go to LNG, will be the LNG 100%. Okay, it's 100% recovery to be the LNG. And N2, nitrogen, will go to the fuel, will be the flare gas. CO2 also. But C6, we will make it as condensate, and so on and so forth. Okay, so that's what I mean with dividing the LNG plant. And we can leave the constraints still blank. Schedule, we will arrive at this point. But the main thing here is the plant process. Okay, so we can close it here. In the next video, we are going to define the pipelines. Until then, see you and thank you.